video is about how to determine the end point. Keep the flask horizontally and tap the corner of the flask 10 to 20 times against the palm. Then rotate the flask for completely turn and observe the movement of the bulk sample. Use the following criteria to determine the end point. If the bulk does not adhere to the internal surface of the flask, and the sample is loose and moves freely following the rotation, that is before the end point. As we can see in this video, the mass of the sample is about 20 grams, and 7.10 ml water is added at that time. So the calculated pore volume is 0.347 ml per gram, which is less than the endpoint value. Then we add 2 to 5 drops of water each time to reach the end point. Repeat the process of stirring and typing. In this video, after 7 drops of water are added, the bulk sample appears as a dense lump adhering to the inner wall. Rotate the flask and tap it lightly. The dense lump falls. After falling, the sample remains the same shape, but repeated fallings break the dense sample into big and firm lumps, each with noticeable boundary as the flask rotates. That is the end point. In this video, the total volume of water is 7.45 ml. The calculated pore volume is 0.364. That is the endpoint value. In this video, after 7 excessive drops of water are added, we see an obvious change. Before rotation, the bulk sample appears as one whole piece of dense lump adhering to the inner wall. Rotate and tap the flask, the dense lump falls. After repeated fallings, the dense lump remains the same shape without breaking into smaller lumps. In this video, the total volume of water is 7.80 ml, and the calculated pore volume is 0.381 ml per gram, 0.017 greater than the endpoint value. This is a summary of the calculated data. The differences of the 3 states are listed.